Hello everybody, this is Mr. Bowen. So today we're going to be looking at the ALEKS topic, finding the present value of an investment earning compound interest. So Mai has decided to invest to help with her retirement savings. How much would she have to invest to earn or to have $132,700 after 19 years, assuming an interest rate of 3.57% compounded annually? Do not round any intermediate computations and round your final answer to the nearest dollar. So pretty standard with the exception of we're rounding to the nearest dollar as opposed to usually this is the nearest cent. So just be careful to make sure you note that. All right, so we need our compound interest formula, which is our amount times the principal, and then times the quantity, 1 plus r over n, which is your interest rate divided by how much or how often you're compounding. In this case, it would be annually, but we'll get to that in a second. And then raised to the n times t power, which is the same number of times how many years, usually years. All right, so go ahead and plug in our values. This one, notice this is what I want to end up with, not my principal, so it's going in for A instead of P. So 132,700 equals P times 1 plus, my interest rate is 3.57%, but I want it as a decimal, not a percent, so 0.0357 divided by the number of times I'm compounding, which is annually, so that's just 1 per year, raised to the n, which is still 1, times the number of years, which is 19. Okay. So now I need to do some cleanup. So I'm going to just bring down this entire first section. So I'm going to do two things here. I'm going to put these together and I'm going to multiply those. So dividing by 1 doesn't do anything. So it's just 1.0357. And then this is 1 times 19. I always recommend doing this as soon as you can because depending on what you have up here, sometimes people will interpret this as 1.19 and that will throw off your answer significantly. So this is 1 times 19, which just comes out to 19. Okay, so now I'm going to need to grab a calculator for that. So bring down this first part, 132,700 equals P. And then this is the part where you're going to be tempted to round. Please don't do it. I'll show you how to do this all in one go. So, but I need 1.0357 times, raised to the 19th power, and it's a very long decimal. It's going to run off your calculator. Just don't hit clear. So it's approximately 1.947356 stuff. Okay, you're not allowed to round this. Don't hit clear. Let's think about what we're doing here. Okay, so I need this number divided by this to get P by itself. Depending on what kind of calculator you're using, that's not too bad, okay? But without clearing this, I'm going to show you how to do it on the majority of your calculators. So you're going to have to bear with me. It's a little bit goofy. If you have a store function, you can just store this number. It's really easy. You just store it and then do 132,700 divided by the stored number. But a lot of people either don't have that or don't know how to use it. So I'm going to show you how to do it anyway. So what I'm going to do is take that number that you have and divide it by this number instead. Okay? So I'm going to do 1.947356 divided by 132,700. Now, hopefully you're saying, but Mr. Bowman, that's upside down. I know. We're going to flip it back in a second. Okay? So let me divide by 132,700. You should have a very small number. This comes out to like 0.00001467, blah. It's very small. Okay? That's because it's upside down. So what you should have is there should be a button somewhere that either says x to the negative first or 1 divided by x, something like that. So either this or this. That will flip your number, okay? So If you have that button, go ahead and hit it, and maybe hit enter, depending on if it does it for you automatically, and it should give you a number that is approximately, because I'm going to round it, 68,140. It's 0.6, so I'm going to call it 144. So that's how you get this, even though your division is upside down. Okay, but your final answer is $68,144 to get her $132,700 in 19 years.